Hey everyone, my name is Venelin, and in this video we're going to have a look at Phi2, a small language model by Microsoft Research that is trying to answer the question whether or not we actually need such large language models in order to get a great performance from the LLMs. And in this case, they are comparing the Phi2 model to a very well-known open source model such as Mistral 7 billion parameters, Llama 2 7 billion parameters, and even ChatGPT. Does it compare to them? Let's find out. If you're interested in large language models and AI in general, I'm going to release an AI bootcamp that will focus on the basics of machine learning and artificial intelligence engineering, if you will. And in this bootcamp, you're going to learn the basics of PyTorch, then how you can develop simple or not so simple machine learning models. Then we're going to have a deeper look into what large language models are. And even we're going to have a look at how you can use large language models such as Llama and Mistral in order to build your own applications and deploy them in production. So if you're interested in joining this bootcamp, please join via the link that I'm going to link into the first comment down below. And the preview of this bootcamp is going to drop on Christmas, so I'll see you in the bootcamp. So why the release of Phi2 is really important? Well, when you're deploying large language models, one of the constraints is that you have to use a lot of resources in order to provide inference and essentially to deploy the models into production. So you need a lot of GPU and then memory. Of course, you want to have a relatively nice CPU as well. So if you have to essentially reduce the size of your language model, then you can get away with simpler or smaller GPU intensive applications, and probably your inference speed is going to be much faster compared to some 7 or even 13 billion parameter models. Even with quantization, if you are having such a small model such as Phi2, for example, 3 billion parameters or something like that, then you will probably have to have a much smaller GPU, and your inference time is going to be much better compared to what you might get with Llama 2 or Mistral. So the research in this direction is really important, especially when you're trying to fine-tune your own models for your own custom tasks. And in this case, we're going to have a look at why Phi2 is a really good baseline. Unfortunately, this model is not available for commercial use, so keep that in mind. You can't actually get it, and you can actually get it from the HuggingFace repository, but unfortunately you can't use it in your own commercial applications, and you can't even fine-tune it as I understand essentially the license of it. So the Phi2 model is a 2.7 billion parameter language model, and it is called small language model compared to what we get from the 7 billion, 13 billion parameter models such as Mistral and Llama. So in this case, Phi2 is actually an incremental release over the Phi1 or a next major version. And you can see that the original Phi1 was only 1.3 billion parameters, while the Phi2 is 2 times bigger compared to that. So it looks like that the number of parameters are really important, and yeah, Microsoft has released this model with 2 times more of the parameters, and they did some clever engineering with the training dataset. So here are the key insights according to the original blog post of this model. So they say here that training small language models that achieve performance on par with models of much higher scale. This is the research question that they're trying to answer. Can they do that in essence? And according to their insights, conventional language model scaling woes with Phi2 are twofold. So what are the main takeaways? Training data quality plays a critical role in model performance. Of course, if you have been practicing any sort of machine learning or AI engineering, you are probably very familiar with that fact. And you are all probably very familiar with the fact that when you are actually cleaning or filtering the unusable data, your models are going to perform better and better over time if you're doing a good enough job with cleaning the bad data from the good data. And this is very subjective, of course, what it means to have good data and bad data. So they say that they're training with a mixture of synthetic datasets created to teach the model common sense reasoning and general knowledge, including science, daily activities, and theory of mind, among others. Of course, they're also training this with a very high number of coding questions, as far as I know. And if you go through the textbooks are all you need technical report, you'll see that they're actually trying to use some code and then some comments, and they're going to essentially create these synthetic data sets using GPT-4 and GPT 3.5. And they're going to use pretty much that for training the Phi-2 model and the Phi-1, of course. We further augment our training corpus with carefully selected web data that is filtered based on the educational value and content quality. I believe that most of the filtering here is also provided by GPT 3.5 and GPT-4. So they're using innovative techniques, whatever that means, to start from the 1.3 billion parameters, essentially Phi 1.5, and embed its knowledge within the 2.7 billion parameter Phi2. I'm not really familiar with how are they doing this, so if you know how they're embedding this knowledge, let me know in the comments down below. But let's have a look at their performance benchmarks and their comparison between Phi 1.5 and Phi 2. As you can see across the board, the Phi 2 model has pretty much 2 times the parameters, the number of parameters. And you see that the common sense reasoning and language understanding are not that much improved, at least overall. I mean, some of the benchmarks, they have Squat V2 and MLU, which are pretty much the standard benchmark according to a lot of the LLM evaluations. You can see here that this benchmark has actually been increased for roughly 10 to 15%, so which is amazing. But the biggest improvement, at least from what I've seen here, is on math and coding. You see that the benchmark increases are roughly 10 or even 20% in some cases, which is amazing. Even that the models are having still a lot less few parameters compared to Llama 2, etc. And I believe that they have another really important benchmark right here, where they're comparing Llama 2 and Mistral with Phi-2. And you see, at least according to their benchmarks, that the Phi-2 model is actually beating Mistral, and it is also beating Llama 2 for the 7 billion parameter on common sense reasoning, that is, and even the 13 billion parameter models, and it is very close to the 70 billion parameter models. Those results look very magical, if you will, but yeah, we're going to see in our little evaluation how this model does. And on language understanding, you see that again, the Phi-2 model is performing much better compared to Llama 2, the 7 billion parameter model, and then the 13 billion parameter model as well. Here, Mistral is beating the Phi-2 model. And here on the math tasks, you see that again, Phi-2 is pretty much beating everything except the 70 billion parameter model. And on the coding tasks, it looks like this model is performing the best by a long shot compared to all of the others. And again, we are going to have a look at how this is performing into a Google Colab notebook when we are trying to evaluate the model on our own. As we've already discussed, the Phi-2 model is actually available on the HuggingFace Hub. And here you can see that it is actually provided by Microsoft. And one of the important additions here is that this model hasn't been fine-tuned with a reinforcement learning from human feedback. So essentially they're using just supervised learning in order to train this model. And again, I want to emphasize this model is intended only for research purposes. Unfortunately, you can't use it in commercial applications. And here they're providing this format, which we're going to use: instruct, then your prompt, then output on a new line. And after the output, you see the output of the model itself. So this is the format that we're going to use. They have also this chat format, which I'm not going to explore, at least in this video. And they have this code format that they're actually providing here as well. One really interesting addition to this Phi-2 model is within the community tab on the HuggingFace Hub. And here you can see that the community has actually run the alpaca eval on the Phi 2 model. And then they did some fine tuning with alpaca GPT-4, which is essentially this model that you can find right here. Even though you can't probably distribute this model, well, at least it looks like that somebody did some fine tuning on it. And you can see something that is a bit disheartening, at least from what we can see here. You see that the Phi 2 model is right at the bottom, at least on the GPT-4 judgment. So you see here that most of the other models are beating it, but the fine-tuned version is performing a lot better compared to what we have right here. So keep that in mind, and when fine-tuning such models, you might actually get even better results. I have a Google Colab notebook that is running on the Google Colab free tier, and we're using our Tesla T4 GPU. So these are the libraries that we need. These are pretty much the latest version of each library, and we essentially need the Torch and the Transformers library, as well as some also other required libraries in order to run Phi 2. And here is how I wrote this model. This is pretty much using the flash or the new flash attention attribute, which we are going to run through using this notebook, and this appears to be working quite well. At least from what I can see, the inference time is substantially faster compared to the original version of this model. And you can get pretty much this from the notebook, or this is essentially copied and pasted from the HuggingFace Hub repository, where the model is actually getting from. And this is how we load the tokenizer. Essentially, this is going to download some remote code in order to run this model for us. And you can see that they're using this configuration file. This is downloaded from the repository, and then they're downloading or loading the modeling file, of course, which is going to be needed for the model itself. So you can see from here that the model is roughly 5.5 gigabytes of storage space. And of course, this is only 2.7 billion parameter model, but still 5.5 gigabytes of storage is not a small feat. So let's see how this model performs. This is the generation config that I'm going to use. I'm going to allow for 1024 max new tokens. I'm going to set the temperature as low as possible so the results can be replicatable for you. And I'm allowing this generation to sample the responses. And I'm going to use this text streamer in order to stream the response. And this is pretty much the way that I'm loading this model. Something that is really important here is to set the generation config that we've created, to set the model and the tokenizer, and then the number of sequences that we want, which is going to be essentially the output of the model, to be set to 1. And these are the end of sequence tokens and the path tokens. I'm going to set both of those to the end of sequence token from the tokenizer, and then I'm going to pass in the streamer. So this is pretty much the setup that I'm going to use. And if you have a better way to set up all of this, please let me know down in the comments below. And this is the way that I'm going to format the prompt. This is going to be following the format from the HuggingFace Hub. If I have a system prompt, I'm going to append it essentially, or prepend it to the prompt. Otherwise, if the system prompt is missing, I'm going to return just the format as is. And this clean doc function is going to do something for us. It's going to essentially remove the padding of each white space, and you get this nicely formatted string. So if you're using the system default prompt that I'm going to pass in your helpful assistant that always answers truthfully, and pass in a prompt, you're going to get a response something like this. And this is nicely formatted, as you can see. So with this, I'm going to start with a very simple prompt. What are the pros and cons of ChatGPT versus open source large language models? So this is a way to start with some text generation from this model. And you can see for yourself that actually the model is providing very nicely formatted response. Pros of ChatGPT: high quality responses, fast response time, wide range of topics, pretty good. Cons of ChatGPT: limited creativity. Interesting. Its ability to generate truly creative or original content, as it is trained on a specific dataset and not more be able to generate responses that are truly unique. Okay, very interesting. Lack of context might struggle to generate responses that are contextually appropriate. Okay. Potential for bias. ChatGPT might be biased towards certain topics or perspectives. Yeah, this is certainly true due to the fact that mostly ChatGPT has embedded, let's say, some ethics that are deemed necessary by its authors, while when you're training or fine-tuning your own large language model or open source large language model, you might choose to add or remove those, if you will. So the pros of open source large language model: flexibility. Again, you can do pretty much whatever you want. Lower cost. Open source models are often free to use, making them a more affordable option. Well, that's both true and not so true. So using open source large language models is essentially free, but still you need some resources in order to host or even deploy those models. And this can be very expensive indeed. So we have community support, are often developed and maintained by a community of developers, which is great, of course. Open source community is amazing. And here are the cons: limited quality control. Yeah, this is certainly true. Limited training data. May have limited training data, which can affect their performance and accuracy. Yeah, of course, I agree with that point as well. And lack of documentation, limited documentation, which can make it difficult for users to understand. Yeah, it depends really on what type of models you're using, but certainly if you get some model from the HuggingFace Hub repository and you just blindly use it, it might doesn't have any documentation associated with it. So overall, the response from Phi 2 is pretty much spot on. Very good response on this question. Let's try something a bit different. What is the most iconic dish that Slavics prepare for Christmas? And Merry Christmas, everyone, if you're watching this during Christmas. The most iconic dish that Slavics prepare for Christmas is borscht, a beetroot soup with meat, noodles, and sour cream. Well, yeah, I think that sarma is actually the best Slavic dish for Christmas. But again, there are a lot of Slavic countries, and probably some are preparing borscht for Christmas. But at least with the Slavics that I know, pretty much sarma is the best thing that you can get for Christmas, even better than some of the presents that your family can give you. So next, I'm going to try to inject a system prompt. You're a salesman and bid farmer know as do I shoot. So I essentially try to put personality to our assistant, and I'm going to try to set it to write an email to a client to offer a subscription for a paper supply for 1 year. And here is the email. You can see that it goes off a tangent right here, but let's have a look at the email itself. Dear client's name, thank you for your interest in our paper supply. We're excited to offer a subscription for 1 year. We offer supply. Our paper supply is made from 100% recycled materials and it's perfect for all your printing needs. We offer a variety of paper sizes and colors. Okay. So I would say this is pretty boring and pretty blunt. Sincerely, Dwight Gage Schrute, salesman and farmer. Well, the personality or the system prompt didn't seem to affect at all the overall response, and I'm not sure why it continues with some code right here. Yeah, but very interesting. I mean, if you try another way to prompt this model, you might get a slightly different response. But if you try to do the input and the output or instruct and output, you see that you get something very similar to this, so not ideal. In the next one, I have 10,000 USD for investment, how one should invest it during times of high inflation and high mortgage rates. So it says real estate, gold and silver, dividend stocks, bonds, cash. Okay, so it looks like this is a very coherent response. It gives you reasons. Again, very, very blunt and very generic. Something you might find pretty boring with these types of models. Of course, with some prompting, you might get much better results, but here we're just getting a feel of the model. And note that even though the responses are quite long, the response time is roughly 27 seconds, which is very good. But still, this model is very small. So yeah, probably if you do some quantization or wording in smaller float sizes, you might even get it to speed up significantly faster compared to what we have here. So let's try something simple in mathematics. Calculate the answer 3 plus 8 minus 2. And you see that you get the correct response. Some of the models are actually, even some of the 7 billion parameter models are providing wrong responses to this one. But this model has provided us with the correct answer. But again, after the response is given, it starts just writing some code. I'm not sure why this happens, but it looks like that the model continues to spew out some random functions. I'm not sure why that is. Probably it might be the case that I'm using this this character right here. This might bug it. I'm not sure. Yeah, but interesting nonetheless. So you get a lot of text through this, and then write a function in Python that calculates the square sum of two numbers. And here we get just the function, and it is very well written. It is by far the simplest function that I've seen from any large language or open large language models in the 7 billion parameter range. Simple and it works well, so great job on that. It didn't do any rambling and explanations, etc. Just wrote the function and it stopped. Again, great job. Next, write a function in Python that splits a list into 3 equal parts and returns a list with a random element of each sublist. And if you do that, you essentially get this. And I'm not sure why. Again, it might be just because we got a new line right here. Not sure about that. But this is essentially what you get as a response, which is, of course, very wrong. And if I try to prompt it in the way that they're actually providing within the HuggingFace repo, you see that I'm writing the def split list, and then I'm adding this comment, split a list into 3 equal parts and return a list with a random element for each sublist. And you see that it is actually providing wrong code for that. It is doing sublist size, which is great, and then iterating over that, but then it is taking just a single random element. And when I've tried to use the alpaca style prompt format, it did actually give me a correct answer, but here that's not the case. I'm not sure why. And again, it failed at least on this task. And again, it continued with some ramblings from here out. It gave us an example usage, which is great, but again, the code is incorrect. And then it continued with some strange text after that. Then I'm asking it to write a function that fetches the daily prices of Tesla stock for the last week, and it calls get daily stock price with the ticker for 7. And just returns that. This is completely nonsensical. I didn't even try to write the function at all. So I would say this is complete garbage. So on these coding tasks, it is failing pretty hard. It might be something of the prompting. Let me know down in the comments if you get it to give you a much better responses compared to my prompting. But yeah, I've tried different ways to prompt it, and sometimes it gave me some code, and still the code didn't work at all. So I'm not sure why Phi2 is performing that bad, at least compared to what we should have expected from benchmarks. But hey, those benchmarks sometimes can be a bit tricky to trust. So here I'm trying to analyze some text. I hope that even my worst critics remain on Twitter, because that is what free speech means. Elon Musk, this is a tweet from him. And if I format this, what is the meaning of this tweet? Do sentiment analysis, rewrite it in the words of Marcus Aurelius. And the meaning of this tweet is that free speech is important and should be protected. Okay, so I agree with that, but it didn't do any sentiment analysis and it didn't rewrite it. So this is very strange. Again, not a very good response. And finally, I'm going to try something, though extract data from this markdown table, use the data from the markdown table, and then the markdown table itself. This is from the Llama 2 paper, and extract the reading comprehension score for Llama 2 7B. And it says that the comprehension score for Llama 2 7B is 28.7, which is incorrect. And I'm going to show you that the reading comprehension here is actually 61.3, I believe. So again, it failed miserably, and this 28.7 is not even in this line. If I in this row, yeah, it isn't actually. So this is really strange. Maybe the next one, the 13B model, but again, not the 7B model. So after that, it just spews out this. It creates a dictionary for the markdown table, and in here you see that the reading comprehension is actually correct, 61.3 for the Llama 2 model. It is creating this dictionary from the markdown table, and after that it says if it queries it, it's still 28.7, which again it is incorrect, if you will. So this is it for the Phi 2 model. I was really enthusiastic to try it out, and the model has some punch, of course, but it doesn't seem to be as good as some of the benchmarks from Microsoft are trying to portray it as. Maybe I'm trying to prompt it in a wrong format, so if this is the case, please let me know down in the comments below. But overall, I think that such model can be a great starting point for your own tasks and fine-tuning it further on your own datasets. Unfortunately, this particular model is not allowed to be doing that. So in general, I would say that if you get some models that are around 3 billion parameters, but are of course free and open source, maybe those types of model can be a great starting point for fine-tuning your own models. Thanks for watching, guys. Please like, share, and subscribe. Also, join the Discord channel that I'm going to link down in the comments below. Merry Christmas, and I'll see you in the next one. Bye.